All right. So population. What is a population in statistics? How can you define population? So again, it definitely depends on how you define it, which group you're considering for your study, which group you're collecting data from, and the way you are collecting data should be able to determine the population size, okay, the group which you are trying to describe. So I'll quickly uh, see the try it now one problem, and then I'll go back to the definition again. Here is the try it now one. It says uh, to determine the average length of trout in a lake, researchers catch 20 fish and measure them. What is the sample and population in this study? Okay, so we know population is the group where we are collecting data from. Okay, it's giving us uh, the set of people or set of things. It could be for this problem. It's the set of trout fishes. So it's giving us a set where we are collecting data from. Now, what is a set? A set is an organized uh, and defined, of course, mathematically defined uh, collection. Okay. Now we know the definition of sample as well. Let me see the definition of sample again, so that it makes more sense. What is that? Here you go. Sample is the small subset of the entire population. Now, what's the smaller subset of entire population? Let's say I have 20 students. If I randomly pick 5 from them, it's the smaller subset. It's a smaller subset of the 20 student set, right? So whenever you have a group, uh, if you define it as your population, and from that, if you just pick a couple of them, not all of those, not all of them, just a couple of those from the entire group, that smaller set is said the sample. Again, let's go back to the problem and I'll come back to it again. So we have a lake, and in that lake, we have obviously tons of trout fishes. We don't know how many of those. Obviously, we can't really determine that. But from that lake, we can pick up, let's say, 20 fish, okay? 20 trouts from that. And we want to collect data from that. Now, can you imagine what it signifies? I mean, the 20 fish, because I'm picking it up, I'm fishing it from the lake, and the lake obviously has more trouts in it, right? So from a bigger set, I'm trying to pick up a smallish one. So can you imagine what it signifies? Is it the sample or the population? Anyone? Just try to imagine, try to use your intuition and find the relation with the definitions. Anyone? No one at all? Just give it a try. Again, I want to spend more time on this so that it makes sense. If it doesn't make sense, then the exercise problems or the examples later on will be really, really difficult to understand. Just give it a try. What does this 20 fish signify? Is it the population? Is it the sample? let me ask from the chat. I don't think you can hear us, but my sound is okay.
Can you hear me?
Yeah, I can hear you.
You can hear that? Okay. Well, the sample is the 20 fish. The population is the trout, however many there is.
Yeah, exactly. Very good. So I was wondering, why can't you hear? Why can't I hear you? Because my sound looks okay, and I can hear you. I can definitely hear you well. I don't understand what's going on. Let me check whether it's the uh, settings or something like that. Can anyone else talk as well so that I can verify that it's working fine?
Yeah, can you hear me?
Yeah, I can hear. So at least my sound system looks okay. Anyway, yeah, thanks, thank you. All right, so yeah, 20 fish is the sample. And why is that? Because in the lake, we have many more fish, right? Uh, obviously, we expect to have more trouts in it, probably some other species of fishes as well. And from that, we're picking 20 uh, trouts, right? So definitely, uh, 20 fish is the sample, right? So what would be the entire population of this study?
All of the trout in the lake.
Exactly, because we are only uh, considering the trouts, right? We're not really bothered about what the other fish, how the other fish are behaving or something like that. We only care about the trouts. So we say that all the trout in the lake is our population, right? Does this make sense? All right, let's see the next definition, and hopefully uh, we can see a couple of more examples of it. All right, so the next definition is the parameter. Okay, I guess we have seen this the last time. Um, there is no harm in going back to it again. So a parameter. So when you're collecting data from a population, a parameter is a value uh, which can be derived from that data. Okay, so wherever I'm getting the data from, uh, this parameter will give me a certain value. It could be the weighted average, it could be the average, it could be the percentage, and all that. So um, this is technically a value from the population. But what if we are considering a sample, not the entire population, like picking up 20 trouts from the lake? So if we are collecting data from a sample, then this value, whatever it is, the average or percentage or whatever it is, this value is called the statistic, not statistics. It's the statistic. You can see the last definition on this page. So that means when you are collecting a value, or when you can calculate a value from the sample, it's called the statistic. Whereas when you can calculate the value from the population, it's called the parameter. Okay, so you need to know the definitions. Obviously, you will not be asked to write it down in your exam or in the homework, but you definitely need to know this, because if you know the definition, uh, you should be able to differentiate which is a statistic and which is the parameter. And we'll definitely see examples of it. Let's see which example we can use. I guess example 2 would be a good fit to it. Let's see that. So a researcher wanted to know how citizens of Tacoma felt about a voter initiative. To study this, she goes to the Tacoma Mall and randomly selects 500 shoppers and asks them their opinion. 60% indicate they are supportive of the initiative. What is the sample and population? Now, is the 60% a parameter or statistic? Excuse me. Okay, so don't look at the solution as yet. We want to see what we can derive from this information. Okay, let's hide the solution first. Okay, so first of all, she randomly selects 500 shoppers. So clearly, it's the smaller subset of the population. Now, the difficult or the tricky part would be to define the population. What would be the population? What would the population look like? Remember, the researcher wanted to know how the citizens of Tacoma felt about a voter initiative. Now, what would be the population? Because this 500 shoppers looks like a smaller subset of something, right? What would be the superset? What would be the population? So clearly, this 500 shoppers is the sample. Can you see that? It looks like it's the sample because it's the, excuse me, it's definitely some subset of a bigger set, right? Because she has picked up 500 random shoppers. She definitely didn't go to everyone in that mall, right? Okay, so 500 is the sample. Now, about the population, it looks like the citizens of Tacoma, right? The people of Tacoma is the population. But we are collecting data from a shopping mall. You could also define that the shoppers at that mall, all the shoppers at that mall is our population. You can also define that because you are only picking up people from that particular shop. If, let's say, if you have picked up 500 shoppers from 6 or 7 or 10 different malls, then it was more obvious that the population of Tacoma, or rather the citizens of Tacoma, is the population here. Remember, this population is not the people we're talking about. It's the population, that means the superset. That means the group where we're collecting data from. Okay, it's not the typical population we know. It could be anything, like we have seen in the previous problem for the fish. So the citizens of Tacoma would have been the population in this group of study. If I have picked up, or if she had picked up shoppers or people from different locations, right, it would have been more obvious. It would have made more sense. But we are picking up people from a certain place, like picking up trouts from the lake, right? So to me, it looks like the population would make more sense if it was, if I just consider it from the mall only, right? And you can see the book also says that the effective population, you can see the effective population was mall shoppers. Clearly, it makes more sense. And I've already described the reason behind it. Can you imagine it? Can you relate to this with the definition? Just try to feel this, because she picked up shoppers from a certain place, right? And we're talking about an entire city. We're talking about the entire city of Tacoma, right? So we're not really clear that whether it would be a good way to say that the parameter, or rather the population, is the entire cities, the number of people in the entire city. But definitely, if I say uh, the shoppers of that mall, then it can definitely uh, be more effective. And you can see the book says there is no reason to assume that the 500 shoppers questioned would be representative of all Tacoma citizens. Right? Does it make sense? These definitions are often tricky. You'll see more definitions and it will be even more tricky because you'll see kind of some ambiguity uh, when you try to use the definitions to uh, relate to your given problems. Okay, we'll go deep into that, no worries. All right, so next question is 60% of them indicate uh, positivity, they're supportive um, of the initiative, and this 60% is from those 500 shoppers, right? Those 500 shoppers signify the sample. So straight away, you should say that this 60% is this a parameter or a statistic? Just remember the definition. If you get a value from the sample, it's called the statistic, right? So is this 60% a parameter or a statistic? Where you are collecting this from?
It's a statistic because they're collecting it from the sample.
Exactly, we are collecting it from the sample. This 60% is from that 500 shoppers, which we have already defined as the sample. And if we can derive it from the sample, straight away, we should say this is the statistic. Okay? Any questions so far? Anything you want me to rediscuss? Again, these definitions are really, really basic stuffs. But as you can see, I want to spend more time on this so that you can feel comfortable moving forward. Okay? All good? All right. Next, we have, oops, why is that? It looks like I've gone too far. When did I scroll down this long, this far? Anyway, let's go back to, oops, I guess it's 227, so. Okay, yeah, we are back. Okay, now next, the next definition we have is called the census. And I guess most of you are already uh, familiar with this definition. So when you operate a survey on the entire population, we call it a census. For example, before the vote, um, I guess you have seen the um, some people coming to your house and taking informations from you about you, your family, how many members are there, what are their names, what they do, you know. So this information they collected for the vote, and um, they have it on file so that they can verify when you cast vote, or they can use this information when, uh, for example, um, creating the budget of how many vaccines would the people in Laramie need, or etc. Right? So uh, this census is not only for human being. Uh, if it's a group of study, whatever the population is, if you have a survey on that, you can call it a census. Okay. Um, Definitely, we'll have examples on it later on. Let's see what we have next. Okay, categorizing data. Okay, so we might have two types of data. When you so in this content, we're definitely playing with data, right? We'll be collecting data, we'll be making assumptions of it, we'll be given a data, we'll be asked to make assumptions on it. Uh, we'll be playing a lot with the data. So we want to know how many types of data we might encounter, we might face. So one type of data would be qualitative, and the other type of data would be quantitative. Okay, so what does it mean? So if you have a data which has numerical significance, that means it will have some arithmetic, meaningful arithmetic calculations. The word meaningful is important here. You'll soon see why. It doesn't mean that you need to have numbers related to it. It doesn't mean it need to have some numerical values assigned to it. It needs to have some meaningful arithmetic calculations. That means the numbers need to have some relations, need to have something significance related to each other. If it doesn't have any meaningful calculations, then it will have some other aspects to calculate or to consider. Like it will have some information which will help us to classify different objects, right? So if it has numerical significance, we say it's quantitative because the quantity will matter. But if the quantity doesn't matter, the quality will. And if the quality matters, then the data will be said qualitative data. Okay. Now, I know this definition sometimes looks, um, you know, uh, incomplete, or it's difficult to understand. It's difficult to see what's actually going on. So let's see one example, one or two examples, and hopefully it will make more sense. Okay. So let's see example 3. We might conduct a survey to determine the name of the favorite movie that each person in a math class saw in a movie theater. Okay, let's do it now. In the chat, write the name of your favorite movie, okay? In the chat, I want you to write the name of the favorite movie you have seen. It doesn't need to be in the theater. If you have seen it uh, um, at your home using any device, that's perfect as well. Okay, I already have one. The Nice Guys. Okay. Princess Bride. Definitely not Terminator 3. Okay. Tenacious D and Pick Up the Destiny. The Avengers. Which Avengers? The first one, or the Endgame, or the Age of Ultron? Which one? Avengers Endgame? Okay, yeah, it's my favorite as well. Toy Story, Mamma Mia 1 and 2. Okay, fine. You can see different. Only two is has actually the same. Avengers, Captain America, Civil War, Forrest Gump. Yeah, that's a nice choice. Fantastic Mr. Fox. What else? Is this Jojo Rabbit or Ho-Ho Rabbit? I mean, is this Spanish? Because this in the Spanish they don't really pronounce J.
It's probably Jojo Rabbit.
Yeah.
Jojo Rabbit. Okay, yeah. But in Spanish they don't really pronounce it, so I was wondering whether it's Ho-Ho Rabbit or not. Anyway, Treasure Planet. I think I've seen that as well. Yeah, I think so. Terminator. Yeah, I like Terminator 2. Not the other parts though. Napoleon Dynamite. Okay. Perfect. So, as you can see, you have different movies. Obviously, when you have, I guess, we are 17 in total today. Interstellar, yeah, that's a very good one. Yeah, 18 in total. So, I assume there will be at least 15 or 16 different movies, and that makes sense. So, that's not a problem. But as you can see, we can't really relate these movies to each other numerically, can we? We can't really do that. This is the quality of the assumption or consideration. How? Because it depends on your choice. It depends on your taste of movie. Someone might like a fiction. Someone might like something really, really tragical. Someone might like, uh, let's say, a love story or something like that. Someone might like um, animations movie. So it depends on your choice, and you can't really say the other choice is wrong or something like that. So it has different opinions, but it definitely doesn't depend on each other, or it doesn't really connect anything numerical. You can't really operate anything. You can't really calculate anything from it, right? You may calculate that we have two Avengers Endgame, but it doesn't really make any sense. We can't really derive anything out of it. So we say this is a qualitative data. It is a qualitative data. Why? There is no meaningful arithmetic calculation here. And you can clearly see that, right? Although I am not sure how many of you can see because some of the names are given in the direct chat. So probably it's not visible to everyone. But yeah, I guess most of you have sent it to everyone. So you should be able to see that. So you can see we don't have any numerical values assigned to it, or it doesn't really give us any other information. So you can't really derive any other information from it. So this data can be called qualitative data. Any question from it? Can you now feel it? Why is it is qualitative data? And why it's not quantitative data? Can you see that now? Right? It should make more sense. Hopefully, we'll have more examples to encounter. Let's see one example where you can find a quantitative data. Okay. Okay. Okay, yeah, we can do this as well. So a survey could ask you the number of movies you have seen in a movie theater or even at your home in the past 12 months or in the past week or so during this spring break. So we can actually have different numbers from it. Let's do it as well. I want you to write how many movies you have seen since we have started this course in January 21st, I believe. Yeah. So since we have started this course, how many movies you have seen? I want you to write in the chat. It may not be the exact figure because obviously if you have seen a lot of movies, you might not remember how many of those you have seen. You might might write an approximate number. Okay. All right, I can say 2, about 5, at least 5, at least 5, 0. Okay, that's interesting. 6, okay. Dozens, 20, really? Okay, 4, 8, pretty good. 4 or so probably, okay. 4, I can see lots of 5s and 4s. But 20, that's great. Okay, 5, all right. So most of you have seen about, approximately 5 movies. If I just say technically from February, so in this last 2.5 months, you have seen about 5 movies. Okay, most of you, okay. Yeah. All right, so as you can see, we have some numerical values, and we can actually have a relation between these numbers. Let's say those who have seen 5 movies, Annie will say, "Hey, I have seen 4 times more than you." Right? Those who have seen 4 movies, Keaton will say, "I have seen 3 times more than you because I've seen a dozen of movies." Right? So you can see we can have a relation between these. We can have meaningful arithmetic calculation. Can you see that? So that means this is definitely a quantitative data, right? Any question from it? Just try to use your imagination, try to use your intuition. Know the definition. Knowing the definition is the first part, but realizing it is the most important thing. You can definitely memorize it, but if you don't understand it, then I don't think it will help. Any question, anything you want me to rediscuss? Because this will be a part of your first homework. Some questions will be pretty similar to this. You'll be given a data and you'll be asked whether it's a quantitative data or it's a qualitative data, okay? And obviously there will be only one answer to it. You either get full credit or a 0. I know it's harsh, but that's how it is. That's how it's set up anyway. All good? Hopefully it will make more sense once we finish today and you go back to your drawing board and try to have all this information on your board, and again re-observing this again and again. Hopefully it should make more sense. All right, let's see why it could be trickier. A couple of minutes back, if you remember, I did say that it could be tricky. It could be really, really tricky. Even though you know the definition, it could be tricky to understand whether it's actually a qualitative or quantitative data. Let's see why. Okay, now let's say we gather some information from different parts of Laramie. Let's say we gather respondents' zip codes in a survey. Okay, now let's do it as well. I want you to write the zip code where you live. It could be here in Laramie. It could be if you're in a remote class. If you're operating it from a different place, you can say that as well. 82072s. Yeah, there will be a lot of 82072s. I know. I live in 82072 as well. 72834. Why is that, Sophie, if you don't mind? Is this in Laramie?
No, that is in Arkansas. I am doing all online this year.
Oh, okay, fine. Yeah, that's cool. 82601, 82070, 68517. Why is that, Arthur?
That's in Nebraska. That's where I'm staying right now.
Oh, okay, cool. Great. Aston, where are you now? 94402.
San Francisco. No, 30 minutes from San Francisco.
San Francisco. Oh, okay. I'm from Reno, Nevada. I've been to San Francisco about 5 to 6 times. That's a nice place.
Yeah, I'm from Half Moon Bay.
Okay, cool. Keaton, where is that? 21061.
Near Annapolis, Maryland.
Oh, Maryland. Okay.
Yeah.
I've been to Baltimore. How far is that from yours?
It's probably about 30 minutes.
Oh, cool. That's a nice place as well.
Yeah.
Okay. All right. Emma, where are you now? It's 75056.
That's Dallas, Texas.
Texas. Okay. Cool. So you can see we have different zip codes from Laramie and even from across the United States. We have the most, you might say, the most western part in San Francisco. We have the most eastern part, let's say in Maryland. So, and we have the southern part as well, Texas. We have Nebraska. I guess Arkansas as well. You know, so these zip codes, you can see these are numbers, but you can't really relate those numerically, can you? Can you say that I live in 82072 and Jordan lives in 82070? That means he is 2 more than mine or something like that. Can you say something like that? You can't, right? So you can't really have a meaningful relation numerically between these or amongst these. Can you see that? That's the beauty of statistics. You can actually see, you can actually visualize what's going on. You can play with these numbers, you can play with this data and use the definitions and basic properties of it, and you can actually find out what's going on. So even though you can see the data is all numerical, we say it's going to be qualitative, not quantitative. Can you see that? Any question from it? You can see this is tricky. These data are all numerical, but it's going to be qualitative. It's not really quantitative. Any question from this? Anyone? Does this make sense? Is there anyone who is still confused? Let me know. I'm more than happy to rediscuss. Maybe I can use another example. Obviously, I will, but if this doesn't make sense, please let me know, okay? All right. Okay. Let's see the next example. Okay. A survey about the movie you most recently attended includes the question, how would you rate the movie you just saw? Okay. So it's exactly the same way I did set up the survey, right? For the course, if you remember how bad my teaching is or something like that. And fortunately, at least 60% of you gave good or better. I had some poor responses as well. I'm not the poor in terms of the number of people. It's the option poor I'm talking about anyway. So you might have different options, right? You might say, the movie was gross. It was not okay. It was a terrific movie. It was outstanding. I just, it was a jaw-dropping performance, something like that. So you might have different opinions, but will that be will there be any numerical relations? Can you find any can you find anything that might give you something numerically? You might rate it 1, 2, 3, 4, 5, anything of these numbers. It looks like numerical, but can you find a relation? Can you derive any information from it. Let's say, for example, I might say it was the best movie ever. I might give it a rating of 5, and one different individual might say no, it was just okay, just about okay. He, like the way in my survey as well, I have different options, different responses, different answers. So can you relate these answers numerically? The answer is no, you can't really relate this, right? So again, even though these responses are in numbers, the possible answers are numerical, you can see you can't really relate those numerically. There is no real meaningful arithmetical calculation, arithmetical relations, right? Can you see that? Anyone? Anyone has a problem or issue with this? Again, this looks easy when you have these automated answers, but when you will be asked to find whether it's qualitative or quantitative, it might be tricky, as I'm repeating again, because even though it's numerical, it may or may not be quantitative, right? It could be still qualitative. Any questions? All right, so definitely your next task will be try it now 3 before we meet on Friday, but you'll only have to do part B and C because sorry, part A and let's say A and B. Yeah, you just need to do part A and B from type now 3, and C will do it now. So I want you guys to have your opinion on chat whether the annual income looks qualitative or quantitative. Remember, the another way to describe qualitative data is to say it's categorical. So often in question, you might see in place of qualitative, it has categorical. It actually means the same thing, okay? No worries. So I want you to write your opinion. Whether do you think the annual income is categorical, or do you think it should be quantitative? And obviously you need to have your reasons behind it. I mean, why do you think it's categorical, or why do you think it's quantitative? Okay, let's do it now. And the other 2 parts, part A and B, it will be due before we meet on Friday. It will be a part of the pre-class assignment, okay? All right, I can't see any answers in the chat as yet. No worries, take your time. We still have 3 minutes for it. We'll not be going to the next topic. We don't have enough time for it, so let's solve it now. Okay, Annie says qualitative. Okay, why is that? No worries,
I said
it's wrong.
qualitative because of all the different jobs people would have. And with my town, we have different areas of like social class, I would say.
Mhm.
So in those areas, it would be completely different incomes because of the jobs available to them, I guess.
Right, yeah. That's a good point. Let's see, what else do we have? It's quantitative because incomes can be compared against each other as greater or less than. Okay, then we have annual income would be quantitative because you can compare the values numerically. Okay, what else? Anyone else has a different observation from the definitions? Just give it a try, even though it's wrong. But don't forget to add your reason behind it, okay? I'll take 1 or 2 more answers before we wrap it up today. Anyone else? I guess Annie had a really good point, but yeah, it's right. It should be quantitative because you can actually relate those numerically. You say that it could be different from each other, and that difference actually says that it should be quantitative because you can actually say that he gets $100 more than me, he gets $20 less than me, he gets double the amount I get, he gets half the amount I get. So you can actually have a meaningful arithmetical calculation, or you can actually see that you can find a relation numerically. Quantitative because the data represents a numerical variable. Yeah, but yeah, be aware of the facts where it's numerical, but it's still quantitative. It's still categorical. Okay. Anyway, yeah. Thanks for the contribution today. I think we had a really great time. All of you contributed to the lecture today. Hopefully, we'll carry on. We'll keep on doing this. So let's meet on Friday. And before that, definitely the pre-class assignment would be try it now 3, and you just need to do A and B because you have already solved C. It should be quantitative because we can compare the values numerically, right? Okay then, so let's meet on Friday.
Thank you.